Hello everyone, welcome to another video. So today we'll be discussing about explicit and implicit functions. So first of all, let's look into the left hand side. So here we are having two examples. If you check, so y is equal to x squared plus 2. So here another example is there, y squared plus root 3 is equal to x, right? So if you check the first example, y has been represented as a function of x, right? Like f of x is equal to y, and y has been represented as a function of x here. So this is an explicit function. When y can be represented in terms of x as a function, it is known as an explicit function. So let's check the second example. Can this be represented in the same form as this one? Let's find it out, right? So first, let's keep only the y squared on one side. So it will be y squared is equal to x, taking the root 3 to the other side, it becomes negative. So it will be y squared equal to x minus root 3. So now we can take the square root on both sides. So it becomes square root of x minus root 3. So now also y has been represented as a function of x. So if you check both of these conditions, y can be represented as a function of x, right? So these are some examples of explicit functions. So now let's see what is an implicit function. If you check the first example here, it says that sine y plus y is equal to x squared, right? But the issue is we cannot take y in one side and taking all the other terms to the other side, right? We cannot take y common from both of both terms have y, but we cannot take y as common from them, right? So we cannot represent y is equal to as a function of x or something. So in this case, this is an implicit function. Check this question also, y squared plus xy plus x squared. When we try taking this y common, it will be y, here one more y we are having, plus x squared equal to 0. So now taking this x squared to the other side, it becomes y is equal to minus x squared. This x squared goes to the other side, it becomes minus x squared, and this is in multiplication. So when you take it to the other side, it becomes division. So y plus x goes to the denominator. So if you check that, in this case y is not actually in terms of only x, right? It also has y on the other side. So this is not an explicit function because we are not having only x here, we are having y also. We need only x on the other side, so then only it will be an explicit function. So this is an example of an implicit function, and this is also an implicit function. When y cannot be represented as a function of x only, it is known as an implicit function. Now let's solve some examples. So first of all, we are doing this question by two different methods. So let's do it in first method like this. So when we are taking the differentiation, we have to find dy by dx here. So when we are taking the differentiation here, we are taking both sides. So d by dx, this side with respect to x, and also this side with respect to x. So both sides we are taking the differentiation. So you can distribute this differentiation to each of the terms. It is just a subtraction here, right? So when it is addition or subtraction, you can just distribute it, and d by dx of pi. So when we are differentiating pi with respect to x, pi is a constant. So the differentiation of a constant will always be 0. So the answer on the other side would be 0 only. So when you take the differentiation, dx by dx would be 1 minus dy by dx. We need to find dy by dx equal to 0. So now this dy by dx we can take it to the other side, so it becomes dy by dx, this goes to the other side and it will be equal to 1. So this is the required answer. So this is one way of solving it without changing the position of y or x and directly applying the differentiation on both sides. Another way of solving it is you can write only one side in terms of y. So we can write the same equation as this way also. So we are keeping the minus y on one side and taking the x to the other side. So it becomes pi minus x. So when we are removing the minus sign from here, it becomes y is equal to the variables change their places. So it becomes x minus pi on the other side. Instead of pi minus x, it becomes x minus pi when we are taking the negative sign on this side. So now we can do the differentiation on both sides. So it becomes dy by dx equal to dx by dx minus d pi by dx. Same thing as before, dx by dx is 1 and pi is a constant, so a derivative of a constant with respect to any variable, it will be equal to 0 only, always. So this part becomes 0, so what is left over? Only 1 is left, so dy by dx is equal to 1. So both methods are same, but here we are writing y in terms of x and other constants, but here directly we are applying the derivative and finding out the answer. Both methods can be used for these kind of questions. Here we are having another question to find dy by dx. So we can use only the way of implicit functions to find the derivative here. So first of all, what we have to do, we cannot write y in terms of x or other constants, right? So first we have to take the derivative with respect to x both sides. So it becomes dy by dx plus d by dx of sine y equal d by dx of cos x. So this one remains the same. This one actually, this one you cannot do it directly. So first of all, what is the derivative of sine? So the derivative of sine is cosine, right? So it will be cosine y. But the variable here is not x, it is actually y, right? Because the variable here is not x, so the answer will not be just cosine y, it will be dy by dx. It is like the chain rule only. First of all, we are taking the derivative of the outside, it becomes cosine of the variable inside y, but the variable is not x, so we are taking the derivative of the variable also. So it will be dy by dx and it will be equal to derivative of cosine x. So here we are having x only, so it will be just the answer would be minus sine x. So minus sine x, derivative of cosine is minus sine and the variable is x only, so no need to write anything. Here we are having the variable as y, that's why we are writing separately dy by dx also. So now what we can do means we are having dy by dx 2 times in this equation. So how we can make it 1 means we can take it common from both these terms, so it becomes nothing is left out in this term. So what will be left out means it will be 1 plus here what is left out, it is cosine of y and it will be equal to minus sine x. On the other side it will be same. Now we are only keeping the dy by dx on the left side and this will be equal to minus sine x in the numerator, and this is actually in multiplication here, so when it goes to the other side it comes to the denominator as it should be in division here. So this is the final answer. Dy by dx is equal to minus sin x by 1 plus cosine y. So when you're having functions with multiple dy by dx, take all the dy by dx to the one side and you can collect the terms and divide it like this. So we are having another question here to solve, and we have to find dy by dx here also. So first of all, let's take the differentiation on both sides with respect to x. So it becomes xy differentiation plus derivative of y squared with respect to x. Then it should be equal to d by dx of tan x and d by dx of y. So if you check here, when we are taking the derivative here with respect to x, here we are having two variables. X is also a variable and y is also variable. So we can have two different variables here. So we have to use the chain rule to solve these equations, right? So first of all, what we'll be doing means we'll be taking the derivative of the first term multiplied with the second one plus derivative of the second one multiplied with the first term itself. Then derivative of this one will be, what is the derivative of y squared? It should be derivative of any constant square, any variable squared will be the power. It has to be written first, then the same variable, then power minus 1. So 2 minus 1 would be 1. But this is not our x, right? It is actually y. So it will not be just 2y here, it will be dy dx also. Dy by dx also will be there because it's not x, it's y squared. So first take the derivative of y squared, it should be 2y, then it is not x, so dy by dx. Then the other side you have to go and check. So derivative of tan is sec squared and it is x only, so no need of writing anything else. Then plus dy by dx. So now here if you check, we have one dy by dx here, another one here and another one here. So what we can do means this side we are having 2, we can shift this dy by dx to the other side, and this one has no dy by dx, so we can shift this to the other side. So it becomes dy by dx with the x here, so x dy by dx plus 2y is here, so 2y dy by dx. Then this goes to the other side, it is plus here, so it goes to the other side, it would be minus, so minus dy by dx, and this all should be equal to sec squared x, and this one dx by dx will be 1, right? Dx by dx will be 1, and we are having y, so y into 1 will be y only, so this y goes to the other side, it will become minus y. So it will be minus y when it goes to the other side. So now we can collect the dy by dx from all the terms. So it will be dy by dx multiplied with x. We are taking dy by dx common, right? So x is left out here, plus 2y is left out, and here minus 1 is left out. So these two have to be equal to each other. So we are just taking the things common. Here minus 1 is left out. So now what we can do means we can write only the dy by dx on one side, and this is in multiplication. So all these terms will go to the other side, it will become in the denominator or division. So this is the final answer. Dy by dx is equal to sec square x minus y by x plus 2y minus 1.